Hi, this is Mick Elliott from Electronic Specifier. I'm on the Rohde Schwarz stand with Holger Gryska, and here we have a new automotive radar sensor test system. Could you talk us through some of the features, please, Holger?
Yes, thank you very much. Yeah, here you see our Swiss Army knife test system for automotive radar. It starts with the anechoic chamber. It's a cut-arc chamber with a parabolic reflector here, which generates a quiet zone of 30 centimeter diameter for large aperture radars. So in a very small form factor. If you compare it with a direct field measurement in a large chamber, this radar, for example, it needs 15 meter distance for direct field measurement, and you can generate this kind of perfect measurement environment with this small chamber using this beautiful reflector here.
Okay, now I understand what's new at this show is some new temperature options and a new antenna. So can you just talk us through those, please?
Yeah, the real highlight we introduced and launched this week is the new antenna feed, which is hard to see in the back here. You can access both polarizations in parallel. And the other hot feature is the temperature bubble. It generates, here you see the base, and over there is the hut. So it generates a temperature-controlled environment around the DOT from minus 40 to 85 degrees. And you can fully characterize the automotive radar in an automated way. Runs everything automatically without manual operation, so very efficient. Today they use some climate cabinets separately, but here you can do it an overnight scan. So.
Okay, and this helps with both characterization and calibration.
Yep. Yes. So this is used in development. They do some performance checking, check the behavior of the chip, if it's heating up and so on, the RF performance. But also later calibration can be done if you go in the direction of for production, like the antenna crosstalk, this kind of stuff. And it's also used for compliance testing. So the regulating test houses, they use this environment also for compliance testing to get a radar approval.
So that would mean it meets ETSI and FCC regulation?
Yes, exactly, you're right.
And if I've done my test results, can I save those test results if the product goes into mass production?
Of course. Everything can be controlled via Ethernet. One new thing, this is also a new use case we are just demonstrating, is interference testing. In radar, this is not regulated today, but with more and more radars on the road, problems start to show up. So what we have here today demonstrate is a DOT with an imaging radar, and you see here some reference targets are generated for let's say a clean environment, and then we inject interference signals, and then you can assess how robust is the radar when you hit the compression point, when the radar is then blind, and this you can all test with this environment.
And the two new options that you've described, they're available now, are they?
The antenna feed is available now, so this is we just launched it, you can order it. The temperature option is an early launch. This is a prototype, and next year there will be the real launch where you can then order and buy it.
Okay. Holger Gryska from Rohde Schwarz, thank you very much.
My pleasure. Thanks for your interest.